Every day, millions of people struggle with poorly designed digital interfaces. Whether it's a confusing app, a cluttered website, or software that seems to fight against you, bad design creates real frustration and wastes precious time. Picture this common scenario. You're trying to complete a simple task on your phone, but the interface is confusing and unresponsive. The buttons don't work as expected, and you can't find what you're looking for. Or consider this example of a complex software interface from the early 2000s. Multiple menus, confusing layouts, and overwhelming options made simple tasks unnecessarily difficult. The result? Stress, wasted time, and the feeling that technology is working against you rather than for you. This frustration is universal and affects productivity, mood, and our relationship with digital tools. Even designers and developers struggle with this challenge. Creating interfaces that truly work for users requires understanding what makes an interface usable in the first place. The good news is that there are proven principles and methods for creating interfaces that people can actually use effectively. Understanding what makes an interface usable is the key to solving these everyday frustrations. Understanding the difference between usability and user experience is crucial for creating effective interfaces. While these terms are often used interchangeably, they represent distinct but related concepts. Usability focuses specifically on how easy and efficient it is to use an interface. It measures whether users can complete their tasks quickly and without errors. User experience, on the other hand, encompasses the entire journey a user has with a product or service. It includes emotions, perceptions, and the overall satisfaction throughout the interaction. The key insight is that usability is actually a component of user experience, not separate from it. Let's visualize this relationship. This diagram shows how usability fits within the broader user experience framework. At the core is utility, whether the product serves a purpose. The second layer is usability. This is where we focus on ease of use, efficiency, and whether users can accomplish their goals effectively. Beyond usability comes desirability, the emotional appeal and aesthetic pleasure users experience. This includes visual design, brand perception, and emotional connection. Finally, the outermost layer represents the complete brand experience, how the product fits into the user's life and contributes to their overall relationship with the brand. In summary, while usability focuses on the functional aspects of interface design, user experience encompasses the entire emotional and practical journey. Good usability is essential for good UX, but UX goes far beyond just usability. Jakob Nielsen, a renowned usability expert, identified 5 fundamental components that determine how usable any interface truly is. These components form the foundation of usability evaluation and design. Nielsen's framework consists of 5 core components that work together to create a truly usable interface. These components provide a comprehensive way to evaluate and improve any digital product. Here are the 5 components visualized as an interconnected system. Each component plays a crucial role in determining the overall usability of an interface. Let's examine each component individually. First is learnability, how easy it is for users to accomplish basic tasks the first time they encounter the design. Second is efficiency. Once users have learned the design, how quickly can they perform tasks? This measures the speed and productivity of experienced users. Third is memorability. When users return to the design after a period of not using it, how easily can they re-establish proficiency? Good interfaces are memorable and intuitive. Fourth is error prevention. How many errors do users make? How severe are these errors? And how easily can they recover from them? Great interfaces minimize mistakes. Finally, satisfaction. How pleasant is it to use the design? This subjective component measures user enjoyment and overall experience with the interface. These 5 components work together as a comprehensive framework for evaluating usability. Each component addresses a different aspect of the user experience, and together they provide a complete picture of interface usability. Understanding these 5 components is essential for anyone designing or evaluating interfaces. They provide clear criteria for measuring usability and guide designers toward creating more user-friendly experiences. Learnability is the first and most critical component of usability. It measures how easy it is for users to accomplish basic tasks the very first time they encounter a design. When users open an app or visit a website for the first time, they form immediate judgments about whether the interface is worth their time and effort to learn. The difference between good and poor learnability becomes immediately apparent when we compare interfaces side by side. A well-designed interface guides users naturally, while a poorly designed one creates confusion and frustration from the very first interaction. Consider this professional 3D modeling software interface. While powerful, it presents dozens of tools, panels, and options simultaneously. For a first-time user, this complexity creates a steep learning curve that can be overwhelming and intimidating. Different types of interfaces offer varying levels of learnability. Graphical interfaces with visual icons tend to be more learnable than command line interfaces that require memorizing text commands. Touch interfaces leverage familiar gestures, while virtual reality interfaces must establish entirely new interaction patterns. This comparison table reveals how different interaction styles affect learnability. Menu-driven interfaces score high on learnability because they present clear options, while command languages require significant learning investment. Direct manipulation interfaces, like drag and drop, leverage real-world metaphors that users already understand. To create learnable interfaces, designers should follow key principles: use familiar patterns and conventions, provide clear visual hierarchy, minimize cognitive load, offer helpful onboarding, and ensure consistent behavior throughout the interface. These principles help users quickly understand how to interact with new systems. Remember, learnability sets the foundation for all other usability components. If users cannot quickly understand how to use an interface on their first encounter, they may never return to discover its full potential. Investing in learnability means investing in user adoption and long-term success. Memorability is the third component of usability. It measures how easily users can re-establish proficiency with an interface after a period of not using it. Research shows that people naturally forget information over time. This is called the forgetting curve, and it directly impacts how users interact with interfaces they haven't used recently. Some products have excellent memorability. Take a stapler, for example. Even if you haven't used one in months, you immediately remember how it works because of its intuitive physical design. In contrast, complex software interfaces often have poor memorability. Users may struggle to remember where specific features are located or how multi-step processes work after time away. Good interface design improves memorability through consistent patterns, clear visual hierarchy, and familiar conventions. These design principles help users quickly recall how to interact with the interface. Examples of memorable interfaces include well-designed mobile apps that use standard navigation patterns, clear icons, and consistent layouts. These design choices help users quickly remember how to accomplish their tasks. Memorability is crucial for user retention and satisfaction. When users can easily remember how to use an interface, they're more likely to return and have a positive experience with your product. Error prevention is a crucial component of usable interface design. It focuses on how well a design minimizes errors and prevents users from making mistakes in the first place. Error prevention means designing interfaces that anticipate where users might make mistakes and building in safeguards to prevent those errors from occurring. This is more effective than simply handling errors after they happen. Here we see a form with real-time validation. As users fill out fields, the system immediately identifies problems like invalid email formats, missing required fields, and password requirements. This prevents users from submitting incorrect information. Compare these two approaches to error messaging. The poor example is vague and unhelpful, while the good example is specific, polite, and provides clear guidance on what went wrong and what the user can do about it. Even with good error prevention, mistakes will still happen. Effective interfaces provide clear recovery options like undo and redo functionality, confirmation dialogues for destructive actions, and autosave features to minimize the impact of errors. Effective error prevention follows these key principles. Be clear and specific about what went wrong, use polite and helpful language, provide actionable solutions, and enable quick recovery from mistakes. These principles create a more forgiving and user-friendly interface. Remember, preventing errors is always better than handling them after they occur. Good error prevention reduces user frustration, increases task completion rates, and creates a more satisfying overall experience. Satisfaction is the fifth and final component of usability. It measures how pleasant and enjoyable it is to use an interface. A satisfying interface creates positive emotions and makes users want to return. Satisfaction combines three key elements. The interface should be pleasant to look at, enjoyable to interact with, and create positive emotional responses in users. We see a satisfying interface experience. The user is engaged and happy, with clear visual feedback, smooth interactions, helpful guidance, and pleasant aesthetics, all contributing to a positive emotional response. In contrast, this interface creates a negative emotional response. The ominous message and poor design choices make the user worried and anxious, demonstrating how bad interface design can harm satisfaction. Interfaces can use various expressive elements to create positive emotions. These include emoticons, pleasant sounds, intuitive icons, and helpful animations that provide feedback and guide users through their tasks. When users have a satisfying experience with an interface, it leads to higher retention rates, increased engagement, positive recommendations, and better task completion. Satisfaction directly impacts business success and user loyalty. Remember these key points about satisfaction. It measures emotional response to interfaces. Pleasant design creates positive feelings. Satisfied users return and recommend the product. And thoughtful emotional design elements significantly enhance overall user satisfaction. Interfaces provide an excellent real-world example of usable design. These machines must serve millions of users daily, from tech-savvy individuals to those less comfortable with technology. Let's analyze this ATM interface using Nielsen's 5 components of usability to understand what makes it so effective for users worldwide. First, learnability. Notice how the ATM uses familiar icons and simple language. The card insertion slot has a clear arrow showing direction, and menu options use everyday terms like cash withdrawal and check balance that anyone can understand. For efficiency, ATMs excel at helping users complete tasks quickly. The main functions are prominently displayed, and the transaction flow is streamlined. Most users can withdraw cash in under 30 seconds once they insert their card. Memorability is achieved through consistent design patterns. ATMs worldwide follow similar layouts and interaction patterns. Once you learn to use one ATM, you can easily use others, even after months between visits. Error prevention is built into every step. ATMs provide clear confirmation screens, timeout warnings, and step-by-step guidance. They prevent common mistakes like forgetting your card by requiring card removal before dispensing cash. Finally, satisfaction comes from reliability and simplicity. Users trust ATMs because they consistently work as expected. The interface doesn't try to be fancy. It focuses on helping users accomplish their banking tasks quickly and securely. ATMs demonstrate that excellent usability doesn't require flashy design. By focusing on the 5 core components, learnability, efficiency, memorability, error prevention, and satisfaction, they create interfaces that serve billions of users successfully every day. Mobile apps with streamlined navigation make it effortless for users to find information and complete tasks. The key is creating an intuitive structure that guides users naturally through the interface. This mobile app demonstrates excellent streamlined navigation. The side menu organizes functions into clear categories like recently viewed, favorites, and settings. Notice how the user profile is positioned at the top for easy access, and only essential functions are included to avoid clutter. Clear, recognizable icons are fundamental to streamlined navigation. These minimalist icons use universal symbols that users instantly understand. They maintain consistent visual style, appropriate sizing for touch interaction, and high contrast for excellent visibility across different lighting conditions. Streamlined mobile navigation follows 3 key principles. First, logical hierarchy organizes content in a way that matches user mental models. Second, touch-friendly design ensures buttons and links are appropriately sized for finger interaction. Third, easy discovery means users can quickly find what they need without extensive searching. Streamlined navigation creates a clear path from opening the app to completing tasks. Users can quickly navigate through menus and accomplish their goals without confusion or frustration. This approach reduces cognitive load, speeds up task completion, increases user satisfaction, and significantly lowers abandonment rates. Remember, streamlined mobile navigation combines clear icons, intuitive labels, and logical structure to create an interface that users can navigate effortlessly. This foundation enables users to focus on their goals rather than figuring out how to use the app. AI-powered personalization represents the cutting edge of interface design in 2025. Modern interfaces now adapt in real time, learning from user behavior to create truly personalized experiences. AI personalization considers four key factors. First, user behavior, analyzing past clicks, time spent on pages, and stated preferences. Second, device type, adapting to screen size and input methods. Third, environmental context, considering location, time of day, and situational factors. Fourth, user intent, understanding the current goal through search patterns and navigation behavior. Here's a real example of AI personalization in e-commerce. After a user adds a leather sofa to their cart, the AI instantly analyzes their behavior, previous purchases, and similar user patterns to recommend complementary items. Educational platforms use AI to create adaptive learning experiences. The system continuously monitors learner characteristics, environmental context, and device parameters to personalize the learning delivery in real time. Modern AI systems excel at recognizing user intent. When a user asks about their account balance, the system processes the input, classifies the intent, and provides a personalized response based on their specific account and context. AI-powered personalization delivers significant benefits. It increases user engagement by showing relevant content, improves conversion rates through targeted experiences, and enhances overall satisfaction by making users feel understood and valued. Intelligent micro-interactions represent the next evolution in interface design. These subtle animations and responses can detect when users are frustrated or successful, adapting their behavior to provide appropriate feedback and guidance. Emotionally intelligent micro-interactions are interface elements that can detect user emotional states and respond appropriately. They detect user frustration or success, respond with emotionally appropriate animations, and adapt the interface to better support the user's current needs. When users encounter multiple form errors, spend excessive time on a task, or make repeated attempts, emotionally intelligent interfaces detect this frustration. They respond by showing helpful tips, using gentler error messages, and even offering human assistance when needed. When users successfully complete tasks, emotionally intelligent interfaces celebrate these moments. They use delightful animations, positive reinforcement, and visual feedback that makes users feel accomplished and encourages continued engagement with the interface. The pull to refresh interaction demonstrates emotional intelligence perfectly. It builds anticipation with visual cues, gives users a sense of control, provides satisfaction through smooth animations, and creates delight with unexpected micro-animations that make the mundane task of refreshing content feel engaging. Emotionally intelligent process flows guide users through complex tasks while managing their emotional state. They reduce anxiety by showing clear progress, provide direction when users feel lost, and celebrate milestones to maintain motivation throughout the journey. Emotionally intelligent micro-interactions represent a fundamental shift in how interfaces respond to users. By understanding emotional states and adapting accordingly, these interfaces create more engaging, supportive, and ultimately more usable experiences that truly serve human needs. Gesture-first interfaces represent the next evolution in human-computer interaction. Moving beyond simple taps and swipes, these interfaces recognize complex hand movements and spatial interactions to create more intuitive and efficient user experiences. Traditional touch interfaces rely on basic gestures like tapping, swiping, and pinching. While effective, these interactions are limited in their expressiveness and efficiency for complex tasks. Gesture-first interfaces expand this vocabulary dramatically. They recognize multi-finger combinations, spatial hand movements, and even air gestures, allowing users to perform complex actions with natural, intuitive motions. Facial interactions take gesture recognition into three-dimensional space. Users can manipulate virtual objects with natural hand movements, point at distant elements, and perform actions that mirror real-world interactions. This creates more intuitive and efficient workflows. This virtual interface demonstrates gesture-first design in practice. Users control menus and select items using hand gestures tracked in real time. The system recognizes pointing, selection gestures, and spatial movements to provide seamless interaction without physical controllers. Gesture-first interfaces dramatically improve efficiency. Tasks that require multiple taps and screen transitions in traditional interfaces can often be completed with a single gesture. This reduces cognitive load and allows for more natural, fluid interactions that mirror how we manipulate objects in the physical world. As gesture recognition technology continues to advance, we can expect gesture-first interfaces to become the standard for immersive applications, productivity tools, and everyday digital interactions. The future of interface design is moving toward more natural, efficient, and expressive human-computer interaction. Task success rate, or TSR, is one of the most important metrics for measuring interface usability. It tells us exactly how many users can successfully complete their intended tasks. TSR is calculated as a simple percentage, the number of correctly completed tasks divided by the total number of attempts, then multiplied by 100. Let's see TSR in action. Here we have a user trying to complete a login task. A successful completion means they can log in without errors and reach their intended destination. However, when users encounter errors like failed authentication, unclear error messages, or confusing interfaces, the task fails and TSR decreases. To measure TSR accurately, we conduct user testing sessions where real users attempt specific tasks while we observe and record their success or failure. Improving TSR requires identifying usability issues and addressing them systematically. Heat maps and user behavior analysis help us understand where users struggle. A/B testing allows us to compare different interface designs and measure their impact on TSR. Small changes can lead to significant improvements in task completion rates. Task success rate is a powerful metric that directly measures how well your interface serves its users. By tracking TSR and systematically addressing usability issues, you can create interfaces that truly work for the people who use them. User error rate is a critical usability metric that measures how often users fail to complete tasks successfully. Understanding and reducing error rates is essential for creating truly usable interfaces. User error rate is calculated as the percentage of tasks that users fail to complete successfully. It's measured by dividing failed tasks by total tasks, then multiplying by 100%. High error rates have serious consequences. Users become frustrated when they repeatedly fail to complete tasks, often leading to task abandonment and significantly reduced satisfaction with the interface. The first way to reduce error rates is through clear, specific instructions. Poor instructions like fill out the form leave users guessing. Good instructions provide step-by-step guidance, telling users exactly what information to enter and where. Helpful error messages are crucial for reducing user error rates. Good error messages explain what went wrong, why it happened, and most importantly, how to fix it. Poor error messages use technical codes or vague language that confuses users further. The best approach is preventing errors before they happen. This includes confirmation dialogues for destructive actions, real-time input validation, disabling buttons until requirements are met, and providing clear warnings before critical changes. By implementing clear instructions, helpful error messages, and error prevention mechanisms, interfaces can dramatically reduce user error rates. A typical improvement might see error rates drop from 25% to just 8%, significantly enhancing the user experience. Remember, lower error rates directly translate to better usability. When users can complete tasks successfully without frustration, they're more likely to continue using your interface and recommend it to others. Iterative design is a fundamental approach that transforms good interfaces into great ones through continuous improvement and user feedback. Iterative design is a cyclical process where interfaces are continuously designed, tested, analyzed, and refined based on real user feedback and data. This iterative process follows a continuous cycle. We start with initial planning, gather requirements, design and analyze, implement and develop, then test and evaluate before beginning the cycle again. The difference between one-time design and iterative design is significant. One-time design involves creating an interface once and hoping it works, while iterative design continuously improves through testing and feedback. Regular usability testing is the heart of iterative design. Testing reveals navigation problems, readability issues, error-prone areas, performance bottlenecks, and user flow confusion that designers might miss. Each iteration builds upon the previous version. Starting with basic wireframes and functionality, designers incorporate user feedback to improve navigation, optimize performance, and enhance accessibility with each cycle. Agile development methodologies like Scrum support iterative design through short development cycles, regular user feedback, quick course corrections, and continuous improvement, significantly reducing the risk of interface failure. Iterative design reduces development risk, improves user satisfaction, creates more usable interfaces, adapts to changing user needs, and ultimately delivers better business outcomes. It transforms interface design from guesswork into a data-driven process of continuous improvement. Exploration of usability, we've seen how good interface design fundamentally enhances the user experience. Usability transforms complex technology into intuitive, efficient, and enjoyable interactions. The difference between good and bad usability is immediately apparent to users. Poor usability creates frustration and abandonment, while good usability creates satisfaction and loyalty. Leading companies understand this principle. They invest heavily in usability because they know it directly impacts user satisfaction, retention, and business success. Usability is essential in human-computer interaction and design because it ensures that technology serves users effectively and meets their actual needs, not just technical requirements. Consider this mobile banking interface. Every element is carefully designed for usability. Clear navigation, readable text, logical information hierarchy, and intuitive interactions that make complex financial tasks simple. As you move forward in your design journey, remember that usability isn't optional, it's essential. Prioritize your users' needs, test your designs, and iterate based on feedback. Great usability doesn't happen by accident. It's the result of intentional, user-centered design.